Okay, so we'll get started, I guess. All right. Good morning, everyone. My name is Bruce Dunn. I'm the chairman of Material Science and Engineering, and I want to welcome everyone to this session on Discover Engineering for Material Science and Engineering. I do want to, first of all, congratulate all our, our recruiting people, the people that we're trying to recruit. You have gotten into UCLA. It's exceedingly difficult for people to get into UCLA, and it's even more difficult for people to be admitted to the School of Engineering. So I want to congratulate you really on what's been your outstanding performance in high school. And we all know that prior performance is an indication of future performance. And so speaking as a faculty member, but I know I speak for my colleagues, we look forward to having you in our classes so that we can enjoy the things that you bring to the classroom, and hopefully you'll enjoy the things that we bring you to the classroom. Okay, so today's program, we have a great mix of faculty, students, and alumni. The objectives is to give you a full idea about what we have here at UCLA in material science and engineering. And so with that, can I have the first slide? Okay, so this is the rough schedule of what we'll probably keep to. So I want to remind my faculty colleagues, you're given 4 minutes. So faculty love to talk, but really we've got to keep things on time. So you'll hear from each of the faculty. There might be a little bit of time to ask questions. I think that'll be okay. And then we'll go on to current students, alumni, and then at the end we have breakout rooms. If you have questions as we go, please do not shy away from them. You use the chat, use the raise hand, we'll figure it out. And Kai, please interrupt us if we have questions as we go, okay?
Sounds good.
Okay, all right, so let's get started. Let me tell you a little bit about material science at UCLA. The whole idea here with our material science program is that we tell you about the behavior of materials, also their synthesis, how you make them, and how you apply them. And it's very much interdisciplinary because we're combining fundamental science with engineering. All our students are very well acquainted with the other types of engineering because many of the applications of materials are not necessarily in material science per se. They wind up going into computer science, they wind up going into electrical engineering, mechanical engineering, and bioengineering. So there's lots of applications for our materials, but we're formed the fundamental basis. And I'm sure you've heard the point that, my goodness, we need a better material. And so that's what we do in material science. That's what you learn about. There's some really great things I think about the department. The student faculty ratio is the lowest in the school, which means we have more faculty per student, and that there's great research opportunities. I'll talk a little bit about that. And we moved into a building, it's now about 7 years old, but it's still quite new, and as campus buildings go. Next slide. Okay, so what does a materials engineer do? Well, that's the whole idea, that we train you to be a materials engineer. You learn about the processing of materials. How do you make materials into useful forms? How do you create new materials? In that sense, part of material science is extremely creative because of the fact we are doing things that nobody's done before. And so this is really why we are very excited about this discipline, because of their opportunities to help in so many different areas of society, really. Production of materials is extremely important. You learn about that as well. And also very important, why do materials fail? And because lots of times you learn a lot when something doesn't work. So there's a number of different materials that we focus on. There's metals, that's the traditional background in material science. There's ceramics, polymers, semiconductors, composites, biomaterials, nanomaterials. All of that is within our umbrella, and all of that you learn about. Next slide. So let me just give you a very, very quick sort of overview of the kinds of things we talk about. If you could hit the next button. Okay, so advanced materials, that goes into aerospace without question. And one of our faculty, Professor Jianmin Yang, who's here, he'll talk a little bit more about that. We also do a lot of work related to biomedical materials, and sports, of course, have a lot of characteristics in common with both biomedical materials and advanced materials, especially aerospace materials. Next, next button. Great. And then, of course, energy today is extremely important. We have a very active research program, and also you learn about in classes. A lot of materials that are used for generating power, such as photovoltaics, other materials that are used in storing energy, and generally how this all works together so that we are able to store energy that comes in from sunlight, for example, and use it in homes. And so this is, sort of the whole idea behind sustainability, and those principles are also taught. Next slide. There's a future, and this is really the things that go on in our laboratories. We are working on ultra high strength materials. A lot of these are nanomaterials, but over the past decade, there's been fantastic advances in this field so that now there's materials that are extremely strong. And this is very exciting. Of course, it's all at a research level, but this is the kind of thing you can look forward to. The next slide. And then there's all sorts of smart clothing, the idea that you're going to be wearing things that are going to be have all sorts of sensors on it to tell you what you're doing, generating power at the same time, and just having complete flexibility in what you do. And then the next slide is sort of the enabling feature behind the smart clothes, and that's the whole idea behind flexible electronics. No longer with things just be on rigid chips, they're going to be on all sorts of different backgrounds and so forth, so you can bend them, you can flex them, and so forth. So that's the future. Some of our details in our department, the total number of students, we usually get about 30 per year, which is great. And so the class size is always less than 35, and that turns out to be really important, certainly from the standpoint of student-faculty ratio and accessibility that we have. We have a very large graduate program, and that just has to do with the nature of material science. A lot of people go into material science in the graduate program because of their backgrounds in chemistry or physics or even biology, and certainly some of the other engineerings. We have a very active research program, $10 million per year, puts us about the third most department in the School of Engineering, even though we are the smallest department. So there you can figure out that we are very active in research. Lots of opportunities for undergraduates to get involved in research. And we actively do that through courses, as well as just students just being around and helping out in laboratories. And of course, there's a very active program by our MRS organization that helps students in terms of their internships. And then finally, there's the aspects of a number of different scholarships. And again, because we have a low number of students, these things are reasonably well distributed among our students. So I think that's my last slide. Is that right? Oh, here's just a list of faculty. And the last thing that I just want to mention is that we are currently 16 faculty and we're growing. We've added 3 faculty in the last 3 years, and we anticipate that we're going to continue to add faculty over the next several years. And the reason is because material science changes, and the way that you keep up with these changes are by adding faculty who have these new talents and these new skills, which certainly drift down very rapidly to the classroom. Now I think I'm finished. I think that's my last slide. And with that, I'm going to introduce Professor He. So, Ximin.
Yes, thank you, Bruce. Hi, everyone. I'm Ximin He. I'm assistant professor in this department. Before I joined UCLA, I did my PhD at University of Cambridge, England, and then went to Harvard University for a postdoc. So my research is bio-inspired soft materials. So basically, we're focused on different kinds of polymeric materials for applications in soft robot, bioelectronics, and energy harvesting. So in next slide, you're gonna see, if Kai, you can click. Yes, so basically we study different kind of polymers. So hydrogel is a type of polymer that is very close to our tissue. As you can see, it has a pores and it's very soft, contains of water, but people usually want to use it with the high robustness. Therefore, we study how we can tailor the nano microstructure to make it approaching the bio tissue that we have in our body. And you probably cannot imagine with this kind of of a soft, gooey material, we can actually do many other things. For example, we can utilize it to create like anti-icing coating, or use it to mimic the sunflower to track the sunlight across the sky. And we can make it like a wearable electronic materials to monitor our bodily function. We can also make it like a smart material to mimic the muscle to develop a soft robot. And we can also 3D print it into complex structure. In the next slide, if Kai, you can help. In the next slide, you will see a bunch of videos to give you a rough idea and how we can utilize to sense the chemical molecules, or we can use it to like a bandit on our finger or body to measure the real-time movement, or we can use it to track the light, as you can see in the sunbot, or we can make it like a self-propeller to swim in water. And also we can chemically functionalize it to make it anti-icing so that the surface won't have an ice cover. So I will just end here because I only have 4 minutes, but it just shows how diverse materials can do even with this soft materials. And later you're going to see many other type of materials from our other colleagues. All right, thank you.
Great. Thank you, Xiaomin.
Sure.
Okay, Zhibing, all yours.
Maybe he lost power like he warned us.
Yeah, let me say that Professor Pei was having a power outage at his home today, he said. And so he didn't know how bad it was going to be. I think we're going to have to move on rather than wait the 2 hours for his power outage to stop. Okay, so that's, okay, great. And then Professor Morris Wang, our newest addition to the department.
Thanks, Bruce. I'm here. Hopefully my house also said power outage, but I have power right now. As Bruce said, I'm the newest member of the department. I just joined the department 3 months ago. My group is mostly working on ultra high strength materials, but we're having a lot of fun. Essentially, most of my group's work is kind of summarized here. One of the most important areas is 3D printing or additive manufacturing. And its broad concept is different type of additive manufacturing approaches. And then we also try to use that approach for the nanostructured material, as well as some of the battery applications for the energy storage. Next slide, please. And sorry. And the type of additive manufacturing we're most interested in, this is actually a movie, I don't know. Oh, it's playing, great, thank you. Yeah, the approach we're using, mostly using approach so-called laser powder bed fusion. Basically, it's a laser, using laser to make powders and making materials with good mechanical properties. And so the research focus area is basically we mainly try to understand how the laser and materials interaction, and using machine learning, because this is very complex processes, try to identify what kind of microstructure we can make. And then we mainly focus on obviously on this so-called structural property relationship. And then we're using a lot of state-of-the-art characterizations in the group, including computer tomography, in situ X-ray diffraction, try to understand the materials behaviors. So we are very eager to recruiting undergraduate students as well as graduate students working on those fun projects, the 3D printing. For us, we consider the material synthesis tool, making new materials, basically. Next slide, please. So as Bruce also mentioned, one of the our strength department, and also my group is working on so-called ultra higher strength materials by trying to understanding how the materials can reach the limit. And one of scaling law we call it Hoyle-Petry scaling. Essentially, the scaling eventually, from the physics perspective, is going to break down. And we try to understanding, how these materials behaviors, how we can reach the max strength. And two types of materials we studied quite a bit is one type is called nanocrystalline materials with a grain size less than 100 nanometers. And the other type of materials are called nanotwin materials, relatively new, which materials actually strengthening this figure shown there. Materials actually strengthening it by so-called nanotwin. It has advantages because nanotwins actually doesn't scatter electrons as much as high angle grain boundaries. Therefore, it gives you outstanding electrical conductivity as well as high strength. Next slide, please. So this is my last slide. This is actually working together with Professor Bruce Tan and on the energy storage. So we are thinking about using 3D printing. In this case, is what we call it direct ink writing. Very interesting material approach. It looks like, you know, oversimplified, but in reality it can be very complex. The idea is we're using so-called direct ink writing to making a 3D electrode, digital electrode for the lithium ion batteries or supercapacitor performance. And this is also very fun. And we are also looking, you know, for undergraduate as well as a master student to join the team. So that's all I have.
Great, thank you. And next will be Yohong Shea, who's the vice chair for the department. Yohong?
Okay, so it's my turn. Hello, everyone. Welcome to UCLA. I have been, my name is Yohong Shea. I've been with the department for over 20 years. I'll think back, that time really flies. Prior to that, actually, even when I joined the department, I was mid-career. So I actually worked in a company for 14 years before joining the department. So I've been around. Now, incidentally, Professor Bruce Tan, when I was doing my PhD in the at UCLA in electrical engineering, Professor Tan was my professor in one of the courses. Till today, actually, I teach that course. So you know, there's quite a bit of history tracing back. So Kai, next slide, please. Okay, here is a brief history of my professional background. And my research area have to do with biosensing and also semiconductor materials and devices. Next slide, please. And also, you know, I am the first generation immigrant, I guess, as you can see, came from China. As quite some of you, I think, participating in today's meeting might be also have that similar background. Okay, as far as my teaching is concerned, I, you know, teach 3 undergraduate courses and 4 or 5 graduate level courses. And I will see you when you get to your 3rd year, 4th year, you'll have to take some of these courses. Next slide, please. Next slide, please. Okay, so a few words about my research. On that front, I would like to share with you, because my educational background is truly not material science. And it's actually physics for my undergraduate degree and electrical engineering for my PhD, master's and PhD. So I might be able to provide a sort of a slightly different perspective as to what is material science. To me, actually, material science is the science that we study how, by adjusting the composition and the structure of materials, to expect certain kind of a response of a particular material under the influence of external stimulation, right? What kind of external stimulation? Well, if you press the material, that's the structural property. You try to watch the shape change. And also if you excite the material with light or electrical stimulation, then that will more likely to fall in the category of electronic material. So my research, starting from 100% electrical engineering, sort of electronic material, let's call it. So we structure materials for exploiting certain electronic response. Till today, my biosensing portion of my research is really also about the stimulation of the material using optical signal, and we try to extract information about biomaterials. So that's it. Next slide, please. I guess that's all. That's all my part. Okay, welcome again to UCLA.
Great. Thanks very much, Johan. You know, I'm glad I passed you after all in that class.
That's the thing. I feel lucky. If we do it again, I may not be able to pass.
Right. Okay. Next is going to be Professor Jianming Yang.
Good morning and welcome to UCLA. My name is Jianming Yang. My research covers a wide spectrum of lightweight structural materials for aerospace applications. A few examples, including carbon fiber reinforced composites for airframe, as you can see here, that both Boeing 787 and Airbus A350, they are using carbon fiber reinforced composite as the major airframe material instead of using the aluminum alloys, okay? But as you probably will know that if you look at Boeing 787 and Airbus A350, they use a different type of carbon fibers. They use a different manufacturing approach. They use a different design methodologies, okay? So there's a lot of challenges of how do we assemble these very intricate structures for aerospace application with, well, very good damage tolerance and durability. Okay. So the second example I'd like to show you is to look at the aircraft turbine engines. As you have probably read the news that back in the late February, United Airlines 777-200 had an engine fire in mid-air. Okay, so the preliminary investigation from FAA indicated that if you look at the front end of the engine, the fan blade for that Pratt & Whitney engine is made out of traditional titanium alloys. So metallic material are very prone to fatigue induced failure. So you need to do a very regular inspection to ensure that there is no cracking, as Professor Dan just mentioned about the material failure. Okay. And some of the newer generation of engine, in fact, that this fan blade is no longer a titanium alloy. It has been replaced by carbon fiber epoxy to reduce the weight, to improve the life, and also to improve the fuel efficiencies. Okay. Looking back at the engine, there are many, many high temperature structural materials which are all based upon nickel-based alloys, which are quite heavy. Okay. So various engine companies are developing new generation of turbine blade materials, okay, based upon ceramic matrix composites, like fiber reinforced ceramics, okay, to reduce the weight, to reduce the needs for aircraft coolings and so on. So this is, again, you will see that for the new generations of engines, new materials are being implemented into the aircraft turbine engines. Okay. And the third example in which Professor Wang has just mentioned, okay, we did a lot of work on additive manufacturing or 3D printing of nickel-based super alloys for rocket engine applications. We're also working on high entropy alloys for these hypersonic aircraft applications. Okay. And we welcome the undergraduate students to join our laboratory to work on these projects. Thank you.
So there's questions, but let me just mention one thing. For those of you who are deciding about whether to come here for your undergraduate education, what you're seeing are very sophisticated applications. If you didn't understand all of it, don't worry about it. If you didn't understand part of it, don't worry about it. That's the kind of stuff you learn. The main thing is that our students learn this over the time, so that even though you might go, I can't possibly imagine learning this, no, that's not the case. You will, really. You'll be brought into this and you'll have the background and the full understanding. So that's my pep talk, to let you know that don't worry. This is what we do. We educate students. with that, any questions for us? You can use the chat or raise hands, either way.
You can also unmute yourself and ask if you have any questions.
Hello, and thank you very much for this presentation. I was wondering, since material science is such a rich and broad field, as you mentioned, and even today I learned new applications that I didn't realize. How does the undergraduate education at UCLA allow us to explore the different applications before we consider, the prospect of joining one of these labs, or even considering the research in these labs?
That's a great question. So we teach fundamentals, okay, so that you understand fundamental properties, strength, electrical properties, optical properties. That's what we teach. And the best way to teach it is through examples. And so this is why, and this is why research is so important, because the examples we bring into the classroom are of the latest research. And so this way you are introduced to literally state of the art, because those wind up being the best way to show how different materials behave. That's really about it. Now, as for joining laboratories, that's really something I think that the MRS student group, when you talk with them, they'll probably have some really good tips about that. Basically, when our offices were open, students would just walk into our offices and say, what kind of research do you do? And is there a position for me? And, and I'd say more than half the time, the answer is, yeah, we can find something for you to do. So I don't know, have my colleagues join in, but it may sound a little haphazard, but we're a small department. And that's one of the advantages of the small department, is that the faculty are always accessible.
We got a few questions in the chat. Kyle asked, there are a lot of graduate and undergraduate students compared to faculty. How easy is it to get to know faculty outside those quarterly meetings?
Oh, that's probably best answered by the MRS students or our alumni. To know us is to love us, although maybe not everybody agrees with that. Would one of the students like to answer that?
Yeah, I guess it's not really the time for student answers, but I'll jump in. I think it's really easy to get to know the faculty. As Professor Dunn mentioned, it's a really small major. So even if you don't say anything in class, somehow your professor automatically knows your name. And it's really easy to kind of get in touch with them and get to know them. And I think like every time I've emailed a professor and said, hey, can I meet up and ask you about something? They've always been very willing to do so. So I think it's really easy to get to know faculty outside of just having your one faculty meeting per year, which you can also have more of if you
want. Okay. Other questions?
How does an undergraduate student go about finding research opportunities?
I think I'm going to leave that for the MRS people. I will leave that for the next session, because I think that they're the ones that are in our labs. As I think I mentioned, from my standpoint, I get contacted or people walk in the office, and that's basically it. So it's really very individual, on an individual basis, the way that I would look at it.
Then one more question before we move into the next session. Someone asked, is teaching more theoretical or practical?
It's mixed. Some classes are more theoretical, and others are really very much towards applications, and so that's the more practical side of things. We have laboratories, laboratory classes which are designed to give you hands-on experience in a variety of different areas that have to do with preparing materials and characterizing materials, and different types of skills we hope are developed in those. So it's designed to be a mix. I should also add that by various measures, we're considered, like, without question, close in the top 10 of all the public schools to be as for our undergraduate program. So, so I think we do a good job of this.
We have to move on, but there will be more opportunities for you to ask questions. So next up, we will have our MRS students.
Hey everyone, my name is Garrett. I use he, him pronouns, and I'm a current UCLA Math Sci student at UCLA. We have quite a few of us here, and we're just gonna be going over some different aspects of student life. And again, all of us are like actual students here. I'm a third year. We have some fourth years all the way down to second years here. So we'll be able to answer a lot of the questions you have about student life that are separate from like the professor side of things. Next slide. Okay, so who are we? So everyone here is a materials engineering student. That's what all of you applied for, I think. And one thing that you guys may or may not know already is you already have sort of a built-in organization being a materials like science student. And that's MRS, which is Materials Research Society at UCLA. And that's sort of just the club for all material science students here. And honestly, there's no better way to describe us than one big family. Because we're such a small major, we all get to know each other really well. Like that being said, so you sort of already have like, literally as soon as you get to campus, you already know all the other Math Scis because your first quarter here, you're gonna start out with Math Sci 10, which we'll be talking about a little bit later, but you already have this built-in family when you get here. On campus, we're leaders in technical projects and organizations. One thing that I love about being a Math Sci student is I feel like we don't do just engineering. We have so many people that do things like not only in like other disciplines, but also we're like dancers, we're student leaders. Like we do so many other things outside of engineering that it doesn't feel like you're just an engineer, which is really amazing. And we're like a super diverse group of people. If you look just like, for example, our MRS board, we're like predominantly women led, if that's probably a concern for some of you. We have like so many different leaders and there's so many opportunities for people to lead essentially whatever you want to do. And just want to reiterate again, like I cannot stress it enough that we're literally just a family. I love being a Math Sci, and I'll let some other people talk about this. Next slide, Kai.
Hello, I'm Claire. I am the incoming EVP. And as for professional events, we have a lot that will help undergraduates get summer internships, co-ops, or just build relations with various companies like Boeing or HRL. And one of the biggest events we host in the fall is the MAE x MRS Career Fair, which includes both companies and national research labs from mechanical, aerospace, and of course, materials engineering. We also have the PPG Primers program in the spring, which is a special internship opportunity specifically for freshmen. Next slide. And of course, since UCLA is a great research institution, we have to have some research events. So typically, we'll help undergraduates get in contact with faculty for undergraduate research positions, as well as getting to know some graduate students within those labs. We also have info sessions and workshops regarding grad school and the application process for that. Next slide.
Hi guys, I'm Emily and I'm the incoming internal vice president for MRS, and I wanted to go over some of the social events that we also host. So MRS does host a lot of professional and academic events because it's super important to get internships and research and get career advice, but we also want to provide balance to all the rigorous engineering coursework. Like school can be hard at times, but we want to help students find a balance between studying and having fun. And so MRS hosts a lot of socials for students to get to know each other and make friends with other Math Sci students. Here are some of the socials that we've hosted in recent years. Every year we host a Halloween social where we like bob for apples, like, and have like a pumpkin carving contest, and it's really fun. And then around Christmas time, we often host a gingerbread house building contest, which we call Gingineering. We all compete to build better gingerbread houses. Here is Royce Hall, and we built lots of other fun things. And last year, we also hosted a hike up the Hollywood sign, which was super, super fun. And every year we host a big event. We host a really big casino night event where people can play poker, blackjack, all that fun stuff. And you get to win really fun prizes. It's a super fun event. I think a lot of students really enjoy it. And we also host some other socials throughout the year. Most years we host a end of the year barbecue where students, undergrad and grad students and faculty can all get together and chat and just have fun. And we also have hosted a kayaking social in previous years where we all went to this marina close to UCLA, and that was super fun too. Next slide. And MatSci, like Garrett was saying, MatSci is a community that supports you in and out of the classroom. Like everybody is super close within MatSci. We really are like a family. Everybody knows each other and stuff like that. I've met some of my closest friends in MatSci, as well as my future roommates. Claire and I are living together next year with another friend in MatSci. So I'm super glad to have met her and my other roommate through MatSci. And yeah, a lot of people in MatSci are super, super close. And overall, it's just an amazing community to be part of. Next slide.
Hello. So we have the Stampy Beam competition, which is our primary hands-on like technical experience for MatSci majors. You have a bunch of pictures here of us actually doing it. So it's a hands-on composite building competition team. For those of you who don't know, composites are essentially when you just mix multiple materials to make a material that's better than both the originals. In this case, it's fibers that are held in a polymer resin, which can be like carbon fiber, glass fiber, natural fiber, anything like that. There's been a lot of really recent things that have been made out of carbon fiber. We actually teach you how to like make that stuff. So you get a lot of hands-on experience, which is really awesome. And the goal of this team is to construct the lightest beam that can hold a design load. For most of the beams, that's actually 9,000 pounds. And the beam that holds that much is normally less than 2 pounds. So these materials are like incredibly strong, and you get to build several a year. We have a bunch of pictures here of us laying up the beam. You can see us, I don't know, just various pictures, and then eventually you break it to see like how much it holds. So this is, and then you also go to competition, which is on the next slide. So this is conference, which is where you actually like get to go, as well as testing the beam. You also get to meet a bunch of materials engineering people who like are also competing in Stampy from not only around the United States, but around the world. This is an international competition. It's a really amazing opportunity to get to network, to look for internships, as well as just the hands-on experience you get from like going, and you get to travel. Last year, it was supposed to be in Washington. Unfortunately, it did get canceled due to COVID, but we fully plan on, or we hope that we'll get to do it next year, like travel again. Next slide. Okay, so that was sort of a lot of intro into a lot of different things about MatSci. If you guys have any questions at all, ask them now. We'll also have plenty of time afterwards with our student panel, and we'll also be on Gatherly way after this event. So you guys will have plenty of time to ask questions, but questions now if you have any.
Oh, Kyle, what does MRS stand for? It stands for the Materials Research Society. It's actually a national organization, and UCLA student chapter is actually the first student chapter. But it's just really cool because they have like conferences and stuff. And then we are the premier club for material science on campus. There was also a question earlier in the chat about what are some of the popular industries that students can intern at, and I thought we could answer that now. Does anyone want to start that off, or should I go for it?
Go for it, Raina.
Okay, so as you know, the professors kind of went through a lot of different fields that material science, like scientists, can work in. I think that applies also for internships. I know a lot of students will go and work in the aerospace industry because that has a very large presence in Southern California, but those aren't your only options. We actually have a partnership with PPG, which is a paints and coatings company, and they recruit directly from like the freshman class. And then you can do a series of internships with them. So that's what I started with. And so I worked in paints and coatings for a bit, for a summer, and then I did an internship at Northrop Grumman that was in manufacturing. You can really do internships in all types of industries. I have friends who are going to be working for biotech companies this summer, also electronics companies. I have a friend who's currently interning at Intel. So really, if it's kind of an engineering company, you can work for it. If it's like, and yeah, so I think there's a lot of options. I even applied to internships at Nike, which you might think of as kind of weird for an engineer, but they do a lot of stuff with material science. So there's a lot of opportunities available to you.
Just sort of echoing what Raina is saying, I think one of the best things about being a materials engineer is the versatility. Because one thing that I really like to say is everything's made out of stuff and we're essentially just the science of stuff. It's like we, in my opinion, are the most versatile engineering major. There's nothing that doesn't require Math Sci, especially like Raina was mentioning, like aerospace. You might think, oh, it's like aerospace engineers who are like building airplanes. While that's true, everyone behind that aerospace engineer is a Math Sci. Like you would be shocked the amount of material science that goes into anything. I also just want to echo again what Professor Dunn was saying. If any of you didn't understand anything of what the professors said, that is fine. When I was here, that all went straight over my head and now I'm doing just fine. It's like, don't worry about not understanding anything we're saying. That's totally fine.
Someone asked, do you have any interesting stories from conferences?
I don't think I have any like super interesting stories, but I do know that I guess it was my sophomore year. The conference was in Charlotte, North Carolina. And for a lot of us, that was the first time we'd been to Charlotte. And so we ended up getting like a small GoPro camera and just carrying that around with us everywhere we went. And it was really fun to just kind of watch back all the weird recorded moments we had. But I think just like in general, conferences are really nice because you also get to interact with a lot of current students, but also just industry professionals. Before I went to my first conference, I didn't really understand how big the field of material science was, but then stepping into a large convention center just full of people talking about even just one aspect of material science was really cool for me. So yeah, sorry I don't have any like super interesting stories. For the question that just came in, it's about talking about the big general classes to smaller MSc classes. So Megan Klein is here. She's a second year. So Megan, do you want to talk a little bit about like the lower division classes that we have to go through?
Yeah, so coming in, let's see, I had like 1 or 2 classes from AP credit, but other than that, I was in my whole first year was a lot of large lower division classes, which you're taking like math series and a physics series. So it's beyond just engineers. Like you'll take physics with people who are majoring in physics and things like that. So those classes are a lot larger than even classes that I'm in now as a second year. My classes the class size has gotten smaller significantly. But let's see, so I enjoy both. I think there's pluses and minuses. Being in the bigger classes allows you to meet a lot of people who are in different majors and see what they're into and collaborate with them and make a lot of friends. And a lot of those classes tend to be pretty general, and you're learning things that there's resources everywhere and you have a lot of people to study with. So that's really great. And then the transition to more upper division material science classes offers new advantages that I think are very important and significant. So for instance, fall quarter, I took a class on X-ray diffraction, which is a pretty niche and cool materials application that really allowed me to dive into material science and determine if this is a place that I wanted to be, and see how passionate the professors are. The first upper division material science class I took with a professor who I now work in his research lab. I really enjoyed getting to know him and seeing the passion for the topic, and it really like inspired me. And from taking that class, I knew that material science was right for me. And I think that a lot of that could have to do with the like small class size. I felt that I was able to really talk to the professor, talk to the people in my class, like everyone there was interested in what we were learning. And so I found that very significant. And then the numbers really, like I mentioned, drastically changed. It goes from like 100 to 200 people in the like major math, physics classes that I took during freshman year to more like 50 now in like the upper division material science classes. So I think there's advantages to both. Don't be too scared in the large classes. Like I mentioned, it's a good way to meet a lot of people and to see what other people are up to. But then the transition to material science classes that are smaller also offers many advantages. And like I said, it's really like inspired me to get more involved in the material science fields, which I think is very important and helps you know where you want to go in your career path and beyond. So hopefully that helps a little bit to answer your question.
Yeah, I also just want to add one quick thing. So I think Garrett briefly mentioned this during the presentation, but in your first quarter at UCLA, you take a seminar class, and it's basically a class just about the major, and it involves like professors talking about their research in a little bit more depth than what you heard today. But also in the past couple of years, we've started adding like actual like hands-on activities that are experiments to kind of reflect some different aspects of material science. And so those are actually run by the undergraduate students actually act as TAs. So you get to work with your fellow incoming mat size on like small group projects and stuff, which means that when you're going to your big lower division classes, you already instantly also have like mat sci friends from that. So if you don't have anyone to sit with, well, you've just met a mat sci in your seminar class and now you can sit with them during class. So that's like a really nice way to also find friends in your lower division classes. And I know I do study groups and stuff with my friends like that.
Yeah, exactly what Raina was saying. I honestly think that the last time I walked into a class and didn't already know like at least 2 people was winter quarter of freshman year. Like the amazing thing about being in such a small major is because you already know each other and you're taking such similar classes, you know each other. So like you get to know a bunch of people really quickly, and like it's honestly such a huge advantage to walk into pretty much any class, including GEs, already knowing people. So you can make friends, which you're expected to do, like, and you probably want to be doing, but like, you don't have to worry about, like, if you want to already know someone, you probably already do. So it's really nice, like knowing someone in literally every class you take for pretty much 4 years. It's wonderful.
Can you guys also talk about how undergraduate students can find research opportunities, and is there a lot of competition between undergrads and graduate students looking for these research opportunities?
Yeah, I can take that. I was IVP last year, so I was in charge of all the research stuff. So on campus, we'll have lab tours, we'll host grad student socials, just to try to get undergraduates to get to know professors and other grad students and then see what they do. But we also do lab tours. It's a little bit harder online, but I'm hoping next year we'll be able to connect undergraduates with graduate students or professors. Not sure if that was the answer you're looking for. Oh, it's not too difficult to find lab opportunities or research opportunities. You just gotta look for it.
Yeah, I'd say the thing that worked for me looking for research was besides like meeting grad students and seeing like if you could help them out in the lab, it also helps to try and go to the lab meetings, because usually either every week or every other week, a lab will meet all together to discuss, you know, what's going on in the lab, the different projects that are being worked on. And so if you have trouble finding a graduate student, maybe see, like you can either send emails to graduate students or professors and ask, hey, when's your lab group meeting? Can I come and sit in and see what's going on? And there you can kind of get the sense of the lab and what they do, see if you're interested in it, and also see if there's like a grad student or a professor that you can connect with to help get you some research experience.
Yeah, and to add on to that, I'd also recommend like cold emailing grad students and professors. Like I've been in 2 research labs, and what I did was like I looked up the faculty on the website and read some of their papers, and then sent them an email saying like, hey, I'm Emily and I really like your research. I'm interested in this aspect. Is there any work for me available in your lab? And so, and then they were like, yeah, sure, you can meet with one of my grad students. And then that's how I got some work in the lab. And I would say that like undergraduates and graduate students don't really compete for research positions, because grad students are often accepted to a particular lab, and undergrads have to email a professor to get into a lab. So I would say that you don't really have to compete with grad students. You don't really have to worry about that. And I would say that like the best way to get research is to put yourself out there.
Right, so David just asked in the chat, from the perspective of getting a job, do you think math science have advantages over other majors like chemical engineering? So I think that in one sense, like the industries can be somewhat different, but like, as we said, like math science is so interdisciplinary, you have so many different industries that you can go to. So you have a lot of different job options. And in some sense, when you're looking to fulfill material science roles, you're only working like trying to, like the only competitors you have are also material science students. And like, there aren't as many of them at the undergraduate level. So I don't think you have to compete with as many people, and you already have a lot more options. So I don't think it's much harder to get a job than like any other major. Like you definitely still have to put in the work, but you have lots of opportunities, definitely.
Yeah, and I think that in general, math sci is very interdisciplinary as far as engineering majors go. You have a lot of different options about what you can get into, because there are, you know, so many different kinds of materials, and also so many different industries that need materials and materials of different types. So I think it's pretty easy to, like, while in school, get a sense of the different kinds of materials and what you like, and like go down different avenues depending on what interests you and what jobs are available.
Okay, there's also a question about online learning. So like most of the university, most of our classes are online, but because we are a very small department, a few of our labs have started to become in person starting from last quarter. It was very limited in attendance, but like we did have that option, which a lot of majors didn't necessarily have. I think online learning has just been an adjustment for everyone, but professors have definitely, you know, worked with us in terms of like trying to record lectures, posting notes, and just making sure that like we're still trying to learn as much of the information as well as we can, even under the circumstances.
Also, one amazing thing about being in such a small major is we're going to be able to get in person a lot faster than some other people. Like, I think we might be the only engineering department to have a hybrid lecture this quarter. I'm actually in the hybrid lecture, so I'm actually going to like a class in person. So that's a really, really, really big advantage. And also stepping off of what Raina said, because we're so small, I feel like professors are also way more willing to work with you in like, as far as like accommodating your learning style. Yeah, so like professors are so sweet. It's honestly just really wonderful.
All right, if we don't have any other questions, I'm gonna pop in a question that's a commonly asked one that you might be too afraid to ask. And that's, do we actually have time for things outside of taking classes? And the answer is yes. A lot of us are involved with at least 1 or 2 clubs. Sometimes they are non-engineering clubs, but we still get lots of time to hang out with friends, visit different parts of UCLA of LA, because the city has so much going on. There's always events happening on campus, and there's definitely time to go and attend them. Garrett is actually an RA, so that is a big time commitment for him, but it's totally manageable. A lot of us are in different clubs, and so yeah, I mean, you have to learn how to be good at time management, but you can definitely be a good engineering student and still have fun in college. It is doable.
Yeah, time management is definitely a skill. I will say there's plenty of things to do and you'll want to do a lot, but I'd say start small, add things on small, especially in your freshman year, because I mean, there's so many cool things to do, but you might overwhelm yourself fast. So pick maybe one club or a few sets of events and build up to it as you see how you personally deal with your course load. Also, don't be afraid to try new things. I know coming in, I got involved in a lot of different IM sports, and it's a good way to meet people and to see what you want to stick with for the next 4 years. And UCLA and MSC does a great job of providing opportunities for you to check things out and see what you like. So that would be, I think, some good advice. Just try to get involved and see what you like.
I'd also say feel free to get involved in organizations that are not explicitly engineering related. I know Megan talked about IM Sports and Garrett's an RA, and Claire and I were both involved in the university's newspaper, the Daily Bruin. I think we all really enjoy doing those things outside of engineering. I feel like it's nice to get a break from STEM and science all the time. And I'd say definitely feel free to try things that are outside of engineering.
Mm-hmm. Okay, so we got a question about the quarter system. So I honestly loved the quarter system at the very, very beginning of college, because I don't know if any of you felt this way. Sometimes in the semester system, especially in high school, you'd feel like you became stagnant, and that gets eliminated with the quarter system. I loved being able to quickly move through material, especially with my lower division classes and GEs. I never felt bored, which can be a blessing and a curse, because you're never bored, but it also means you're never bored, which does mean we're moving through a lot of material very quickly. So you do have a little bit less free time than I would say if you're in the semester school. But I do really enjoy the feeling of never feeling stagnant. It does change a little bit when you get to upper division classes, because you're moving through a lot of material. But the amazing thing about moving through so much material is you have such an advantage over people who are on the semester system, because you get to take more classes, especially once you get into your engineering electives, like composites, or one of my favorite classes was an archaeomaterials class. You get to try out different things because you have more classes that you get to take. So I will say that you're learning more, which means you're busier, but it means that you get to learn more, which I don't know if that makes sense. I hope that makes sense. I'm gonna just leave it at that.
I will say that the quarter system is very fast paced. You have to have a lot of good time management. Because it is so fast paced, you literally cannot take a week off or else you'll be really behind. For lower dis, you usually have 2 midterms. So that's week 3 or 4, and then 6, 7, 8-ish area. And with 4 classes or 3, you'll usually have a bunch of stuff piling up towards the middle. So just kind of throwing that out there, that you want to be pretty conscious about your due dates and your time.
Yeah, and I will say one thing is that in the quarter system, midterms is not so much a week or a season. It's more the whole quarter, especially in lower divs. Usually professors will do 2 midterms. So I'd say once like week 3 or 4 hits, just expect to have midterms throughout the rest of the quarter. But generally they'll be more clumped around weeks 4, 5, and 6. But there will be some professors that will be, oh yes, week 10, it's time for a midterm.
Do we have any more questions? If not, we'll be moving into the next session now.
I guess I'll start off. Hi, my name is Catherine Berry. I am a recent alumni. I graduated in spring of 2020 with my bachelor's in material science and engineering. And then I'm a current student. I'm in a PhD program at Johns Hopkins University. So I'll just keep this really brief and introduce myself. I'll be around during the breakout sessions if you have any specific questions, literally on any aspect of, you know, student life to graduating to kind of a life after recent graduation. So I'll be around. Hopefully I'll get to talk to some of you guys.
Okay, you want me to go? Ooh, I made it on time. Sorry, I was waking up my son from his nap. So hi, I'm Stephen Chun. I am a 2006 graduate from MSc, and then also 2008 master's degree. Born and raised from Hawaii, you know, moved from the islands to UCLA. Thought I would finish my degree in 4 years, go back home and surf, but that was not the case because I fell in love with material science and engineering. I'm gonna say it really started with the student body and the professors that really kind of molded my career to where it is now. That's why I'm here, and I'm excited to tell you what my progression of my career was. Right after graduation, in my BS, I went to my master's because I wanted more hands-on experience, and also I had a hard time finding a job. But that was because I really wanted to understand more about material science before I went into the field. Got a job with Boeing as a failure analyst engineer. So what that is anything that fails, I had to retell a story why it failed and whose fault it was. So I would like to say it's like kind of the modern day Sherlock Holmes, where you go into some room, some kind of mystery happens and you have to figure out and really retell a story. So I like to talk a lot and I like to tell stories. So it was like perfect for us being a nerd. So that was my first job. Worked at Boeing for 9 to 10 years. Kind of went from failure analyst to leading a team of 7. And then I led 22 people down in the Southern California region, both failure analysis, working on products like satellites, Apache helicopters, Boeing airplanes. And then I got reached out on LinkedIn to work for what I like to say, the recruiter was, do you want to work on a anniversary program for something? And so I knew that this was going to be the iPhone because it was a 10-year anniversary. So I was recruited to program manage the operations reliability of the iPhone. So what that was anything that went wrong with the phone, I had to understand that before mass production. So that's drop tests, that's bend tests, that's cracking, electronic failures, you know, everything that kind of I learned in MSc, kind of put together, and program manage that before we launched, you know, and sell 1 million phones a week. Did that for 3 years, kind of crazy. And then I switched from engineering to now I am straight operations. So it's like supply and demand and logistics, super different. I transferred to Apple Beats, the headphones. So now I run all new product introduction and sustaining programs for Beats headphones. So now it's like kind of, they wanted to bring someone who had a technical mind, but who could also drive the programs and understand logistics and supply and demand. So really from, you know, education based to aerospace to commercial products and to now, yeah. So it's a very interesting pathway with the MSc background. I can keep going.
Well, maybe I'll jump in. I'm a late addition to the panel, and my name is Jim Barry. I'm a 1988 PhD graduate from the materials department, and I've stayed involved at the department over many years through my career in the aerospace industry, where I work on optical materials for spacecraft. And I've also been had the experience of being a parent of a student in the materials department. So in the breakout session, if people have questions about longer term careers and your experience of your children as they go into these programs, I'd be happy to field questions. Over.
I guess there's a question in the chat about how many students go to graduate student and then go to industry. I think it does change year to year on the climate. If you had asked me this 2 years ago, I would have said majority of the people go into industry and a smaller percentage go into graduate school. But now, given the pandemic and the change in the job market, I think we've seen a much greater push towards going to graduate school as opposed to industry. And I'm sure that'll change as we're coming out of the pandemic as well. The benefit of UCLA is we get that option. We are trained to, be able to do both. I, in particular, chose to do graduate school immediately out of my undergraduate career, but I know plenty of people who have chosen to go and pursue a job and have, enjoyed doing that as well. So I think it's very, I think a breakdown a couple years ago was 50-50. I have not seen recent statistics on that, but that is kind of my feel as a recent graduate.
Yeah, I just want to echo what Catherine says, like really going back to UCLA gives you the opportunity to either go directly or actually even go to graduate school while you're working. I have to say the professors really helped guide me in my decisions for graduate school, for my master's, and then to continue education while I was working at Boeing. And I went back to do some classes for my PhD and my oral examination. Then I got too busy after that. But having that conversation and that relationship with the UCLA professors in material science really, again, I say mold my career and my personality, and just being there helpful to help you on a personal basis also. I really appreciated that. So really look towards something that if you come to UCLA, that's definitely something there.
And the department, maintains that strong relationship with, with the alumni. And so there's a lot of participation. There's a lot of, alumni that are hiring, students and giving them the opportunities to see what an industry experience is like, for summer internships. And then we have a number of the alumni come back and teach courses as well to give students, again, the experience of the perspective of industry in engineering, and not just academic research. When we hire UCLA students to do, internships, we usually try to give them both the sense of what working in industry is like, but also the sense of working on a project that would be kind of a master's level, research, so that they can start to make decisions about whether they want to pursue industry or grad school.
Any other questions? You can feel free to unmute yourself and just ask. Someone asked, how helpful is UCLA many years after graduation?
I would say the reputation of UCLA has grown over the years, it has become more and more valuable to be associated with UCLA and to be a Bruin. You know, the networking, you know, there's always the stereotype of the, you know, the Ivies and the networks and all that, but UCLA, there's a tremendous number of graduates, you know, worldwide and across the country in prominent positions, and having those connections is great. And so I've been active with the Alumni Association for many years. And I'd say it's a helpful thing. The ability with materials, what's really nice is the department's small. We still have personal relationships with faculty and other students. And so the ability to go back on campus and you know, continue to learn and continue to see what's going on, you know, at UCLA and in the tremendous research of, you know, all the new things going on is wonderful.
And then let's see, how helpful is UCLA? So on a personal level, I still think UCLA is very, just having that name and the friendships that you make. I mean, gathering for the Final Four, you know, gathering for the March Madness, like that's a big part of it also. And then engineering wise and the material science program, I met a couple of my peers at Apple, having lunch with them, just looking on LinkedIn, like, oh, you're at Apple, you're UCLA MSE. And that was always a nice network to have, to see familiar faces and to build your network within your own company. So I thought that was pretty amazing.
I guess I won't speak to how helpful UCLA is many years after graduation. So I'll answer the next question as to transition from high school to college, since that was more recent for me. So I think it very much depends on, first of all, your high school education. You know, some schools are better at preparing you for the college experience than others. I personally went through public school all through my schooling before getting to UCLA. And I think it's very common for people to struggle with that transition. But the benefit of being a Mat Sci in particular is you kind of already have a built-in support network. I knew immediately after coming to campus who to go to when I was struggling with classes. Actually, one of the very first events I went to with the Materials Research Society, we went and just had a social dinner. But as a freshman, they, you know, most of the upperclassmen said, oh, I have a bunch of textbooks that I found really helpful that I have on like a Google Drive. They were really helpful in my lower division classes. And so they gave them to me. And that sort of inside network on kind of how to navigate that transition is really helpful. So I think it, you know, regardless of what college you go to, it's always going to be some sort of transition. But I think a benefit of UCLA and material science at UCLA in particular is that support system you have.
And also,
go ahead.
Okay. I'd also like to answer that question about the transition from high school to college. I had a sort of unique experience. I am both an out-of-state student and someone who graduated from a very small high school, like graduating class of 31. Also, shout out to all the out-of-state students. Like, transitioning to another state for college is hard, regardless. But I also very much want to echo what Catherine was saying, that having an automatic support system of Mat Sci makes your life so much easier. And I also have a very, very similar experience with Catherine about like getting a bunch of support from upperclassmen. It makes the transition so much easier, especially coming from a small school. Like UCLA has as many students as my hometown does total population. So it was wild going from the middle of Idaho to Los Angeles. So just want to say that like having essentially a family when you move just makes everything easier, and it made the transition wonderful. So I just want to add in my 2 cents.
Do they still have that intro class for Mat Sci?
Yes, we still have Mat Sci 10, and it's wonderful.
So just, you know, what Garrett's saying, you know, coming from out of state, you know, coming from Hawaii and then coming to UCLA where I had like 4 other classmates that came. And it is, I think on a personal level, there is a lot of changes no matter who you are, right? If you're an extrovert, it might be easier, but if you're an introvert, I totally understand that it could be daunting because UCLA is such a big campus and you feel like a number. But the MatSci program, even with the intro class, is you'll meet your fellow classmates that you'll be taking classes with for the next 4 years. I think that's something very unique that I haven't heard from other colleges and other programs. I am still very close to every single one of my classmates from MatSci. We still see each other, we still talk to each other, you know, with social media, we still definitely keep in touch. 2 of them I'm gonna see in Hawaii, you know, coming in June. We're vaccinated, don't worry. Wear masks. But it's such a great network in that sense. So if you're a little bit nervous of meeting people, you know, MatSci will be there for you. And this MRS club too, like that was the whole point of starting this program when I started school in 2002, and we started this club in 2003 or 4, was to bring our relationships closer together. It was just about, hey, let's go get free pizza, and let's you know, together. That's how it started. And then now look how much this has blossomed. So this is great. And then, you know, okay, the next question I see from Ashley online is like, how strong is the alumni network for UCLA engineering? It's not just engineering also. It's like, even when we travel abroad and I wear something that says UCLA, people will come up to me and be like, oh, I went to UCLA. And you have that conversation. I think that's one of those like smiles that you get where it's like, oh, what a great school. So that's something to think about too.
Also, as far as like the alumni network goes, one amazing thing about UCLA, it's not exclusive to engineering, is we have UCLA One, which is just this absolutely massive network of UCLA alumni, and you can search through them by like major or by what career they're in. A lot of undergraduate students use it. I haven't personally used it, so other people might be better for details, but essentially what it does is you can get an alumni mentor. And I know personally I've been able to apply to internships actually through my friend's alumni mentor. So we have like an absolutely massive alumni network, and you don't only have access to those who are MatSci. So like if that's something you're worrying about or like curious about, it's huge.
And then just to add on to that, this past summer, I was like trying to figure out what field I wanted my career to go into. And I ended up just cold messaging people on LinkedIn who are UCLA alums. And these range from people who are in the LA area to in the Bay Area to out of state. And almost all of them replied to me really welcoming to be like, yeah, let's have a virtual coffee chat. And I just talked to them for half an hour. And these are people that like I've never heard of before. And it's just because of the UCLA connection that they're like, yeah, I want to help another Bruin out. And they were talking to me for like half an hour. And it was just, honestly, it was such a great experience to know that my UCLA support system extends beyond just the undergraduate community.
Any other questions? If not, we can start our breakout rooms early. Okay, so we will have 5 different breakout rooms. There are academics, career paths, internships, research, and student life. You will be able to choose whichever breakout room you want to go into, and then just have a more personal chat with our students and alumni and faculty members.
Wait, so we go into it there now?
Yeah, you should have gotten the notification.
Okay, you sent out the link, right, on email?
It's in the same meeting. You should have seen the little notification that says the breakout room has started.
What is this technology? Wait a second. Sorry, we use WebEx.
Or at the bottom, do you see at the bottom of the Zoom meetings,
okay,
option that says breakout room?
Got it. Sorry, we don't use Zoom. And then what, I just click on it?
Yes, just choose the one that you want to join.
Wait. Okay, wait, I press breakout rooms and then now a list pops up, but how do I get into it?
I can put you into which one did you want to go to?
Okay, career path, please. Sorry.
No worries. Let me...
It's software, I don't know. Join.